Welcome to the second video on C++ in UG Academy. In this video, I'm going to talk about the basic types of data in C++. First, we have the list to have a look. There are 7 fundamental data types in C++, namely Boolean, true-false value only, character. They can be represented as integer value, but usually they are typed as character within the program. Later we'll see about that. Sort, which is a type of integer variable. It takes integer value in this range. The integer type take integer value within this range. The long type, similar to the integer type, but it may behave differently in 64-bit system and 32-bit system. And also the float data type. This E here stands for exponential. Okay. We also have the double data type. Its range is similar to float, which can take decimal value. However, it has higher accuracy and a larger range. And these different data types take in different amount of memory space within the machine. In terms of bytes listed here. Okay, so we have now known the basic data types within C++. Let's have a look at how we can determine their size within a program. We can use a default function called sizeOf to print out their size. Here is a list of size of data variables in C++. Okay, so let's have a look at how do we actually define variable of different type. In this program, I have defined 6 different variables of different commonly used data type. The first one is being integer. We define it here. N equals to 10. Since C++ is a way of writing program, it's like usual sentence. We separate our statement in sentence. As a program, we will split our program into different lines, and the computer will execute them one by one. In C++, every single statement or line is separated by a semicolon. Okay, this one. So after we have typed one statement, we need to type this to tell the computer that this statement has ended. Then we go on to the next line for the next statement. So in the first statement, I define an integer variable called n, take the value 10. And then similarly, in the second statement, we type in the keyword float, and then define the variable name as x. Then we define a float variable taking the value 1. Similar for double, which is an enhanced version of float, and then Boolean value, which take in true or false. And then also the character here. For character, although it actually can be represented as integer value, we usually represent it using a single column quoting a ASCII character. ASCII characters are just those you can find on your keyboard without any foreign language typing kit like the Chinese typing. So we have assigned this character A into a character variable C. The next thing here is related to character. However, it's actually an array of character. We call it string in C++. This variable here is slightly more complicated. We will come back to it later. Just to put here to show that this is actually how we use double quote. In contrast with the single quote we use to define A. We use to define character. So this is actually a difference here between Python and C++. In Python, we can use both single quote and double quote to define string. However, in C++, single quote is for character, and then double quote is for string. And we can also use the sizeOf function to print out the size of different size of the variable. The ENDL here actually stands for n9, so the console will go to the next line to output the size of the next variable. Okay. However, when it comes to C++ variables, things can be a little bit complicated. First of all, we actually have some type of character called special character. We use a slash plus alphabet to represent it. For example, /t can represent the tab character, /n represent the new line character, and /b represent the black space. Okay. Also, there is the character and integer correspondence. As you can see here, the character 0 can actually be interpreted as the integer value 48. Okay, so this is called the ASCII encoding scheme, and this encoding scheme allows we to perform arithmetic on C++ character, and this can sometimes be useful as well. Okay, and for Boolean data types, there is also other interpretation other than true and false. For example, false can be interpreted as 0, and 0 can be interpreted as false. And then true can be interpreted as 1, and the contrast is, and the reverse is true as well. Okay. And then there's also the underflow and overflow issue with integer data types. When we talk about underflow, is when we perform certain arithmetic on the variable such that the value of the variable actually go over its range. The range is shown here. So if we add like 20,000 to 20,000 to sort, then it will overflow the range of sort. When overflow occurs, something weird can happen. So we advise you to beware of the variable type you are using. Make sure it will not overflow. Otherwise, the value will be an error. Okay. Underflow is possible as well, which means the value of become too small and then go out of the lower limit of the variable range. The same is possible with floating point variables as well, including float and double. But floating point are generally harder to overflow because their value ranges are much greater than integer value. But we still have to be aware of it. Often talking about variables, we are going to talk about constants. Other than variables, we can also define constant in C++. The syntax of defining constant is similar to that of variable, but a keyword const is added before the variable type. The purpose of defining constants is usually to make things easier, which are those things that take a particular meaning but do not have to change over the course of the program. Since constants usually do not change within the program, memory is not allocated for a constant. The compiler, you just plug in the value you defined during compilation. That means during translating the C++ program into an actually executable. So after talking about constant, we can go on to talk about the rule for defining variable. The same applies to defining constant as well. Basically, the only difference between constant and variable is that you cannot change the value of constant. And then when defining constant, you should add the const keyword before the variable type, before the data type. Okay. Then, when we talk about the length of variables, such as n, x, xx in this case, they actually have a more official name. They are called identifiers. And when we create identifiers for C++, there are some specific rule. Usually we won't break it, but just to let you know, so that you can keep your program error safe. First, the reserved words are not around. What are the reserved words? It's very hard for you to encounter them, but here is a list. So you cannot use this type of word. They represent certain type of program that have some specific meaning within the program, or they actually represent a data type, so you can't use this. Also, identifiers are case sensitive, so uppercase letter and lowercase letter do make a difference. And we should also try to make identifier meaningful. This is by using camel case or underscore if the variable name is longer than one word. Okay, in this video we talk about the common basic data types within C++, as well as define constant and the rule for creating variables. In the next video, we are going to talk about some basic control flow of our program, as well as some basic arithmetic within a C++ program.